In this lecture, we will discuss about the monsoon mechanism and in particularly the very thermal concept of Indian monsoon. Monsoon is actually a wind regime operating at a level of 20 kilometers from the earth's surface. It is characterized by seasonal reversal of wind direction at regular intervals. Although the monsoon is a global phenomenon influenced by a variety of factors not yet completely understood, the real monsoon rains cover mainly the South Asian region, represented by India, Myanmar, Sri Lanka, Bangladesh, Bhutan and parts of Southeast Asia. Besides the monsoons, the Indian climate is influenced substantially by two more factors. The Himalayas contribute a continental nature to the climate, recognized by land winds, dry air, large diurnal range and scanty rainfall. The Indian Ocean, on the other hand, contributes a tropical character to the Indian climate, characterized by uniformity of temperature throughout the year, short diurnal range, damp air, and frequent rainfall. The monsoon system of Indian subcontinent differs considerably from that of the rest of Asia. The centers of action, air masses involved in the mechanism of precipitation of the Indian monsoon are altogether different from other monsoon systems. So the very thermal concept of Indian monsoons, differential heating of land and sea at the same time when the sun makes an apparent northward movement, it is the main cause of the Indian monsoonal rhythm. Two factors are mainly responsible for this thermal heating, and these are: one is vast size of the Indian subcontinent and adjacent seas. Second one, very high and extensive mountain systems of the Himalayas in the north, extending in an east-west direction, thus posing a formidable physical barrier between tropical and polar air masses. The second factor is of great meteorological significance. The high mountain chains of the Himalayas, which border the subcontinent on three sides, work as both a brake and motor at the same time. During the winter season, it prevents the penetration of the cold polar air masses from Siberia into the subcontinent, while in summer the Himalayas do not allow the equatorial maritime air masses to cross the northwest. The mighty Himalayas produce hydrodynamic effects that determine the type of precipitations in India. According to the thermal concept, during the period following the spring equinox, that is March 23, the sun starts its apparent northward shift. As a result, the areas living and lying north of the equator, tropics and subtropics, get a progressive high incidence of solar radiation. The effects of this phenomenon on the Indian subcontinent is in the form of intense heating of the vast northern plains and the adjoining highlands. As a result, a massive low pressure through is formed extending from the Punjab plains in the northwest to the Bengal Delta in the east. This low pressure zone attacks wind regions from the adjoining areas from short distances in the beginning. But as the level of solar incident reaches its peak during the month of May and June, the pressure gradient between these low pressures through and the adjoining areas is so great that it attracts winds from as far as the south of the equator. Accompanying this process and helping this pool of wind regions is the development of some high pressure centers in the Indian Ocean, Arabian Sea, and over Australia as it brings winter season in Australia. The wind patterns which are prevalent south of the equator are actually the southeast trade winds which blow from southeast towards the northeast. These winds attracted by the low pressure over the Indian subcontinent while moving north of the equator turn in a clockwise direction or towards the right, following Farrell's law. This shift in direction is brought about by the Earth's rotation. Now the originally southeast trade winds become southwest monsoons blowing towards the northeast. At this juncture, the intertropical convergence zone also shifts northwards. The intertropical convergence zone is the hypothetical line where the northeast trade winds from the northern hemisphere and the southeast trades from the southern hemisphere meet. The southwest winds now approaching the Indian peninsula have to travel a long distance over the Indian Ocean. During their long journey, these winds pick up large amounts of moisture, and by the time they reach India, they are oversaturated. Here they are known as southwest monsoons, which get divided into the Arabian Sea branch and the Bay of Bengal branch because of the shape of peninsular India. These moisture-laden winds cause heavy rainfall on the windward sides. So, now we'll discuss, after completing the thermal concept of Indian monsoon, we'll go to Arabian Sea branch. This branch of the southwest monsoon strikes the highlands of Western Ghats at almost right angles. The windward slopes of the Western Ghats received heavy organic precipitations, although The western currents of monsoon penetrate further into the Indian mainland. The intensity of rainfall goes on decreasing on the leeward side, while the windward slopes of the western Ghats are the areas receiving the highest rainfall. The leeward slopes form a well-marked rain shadow belt which is drought-prone. For instance, the average annual rainfall at Bombay and Pune is 188 centimeter and 50 centimeter respectively, despite the fact they are only 160 kilometers apart. The most characteristic feature of the distribution of rainfall on the windward slope is that the amount of rains is heavier higher up the slopes. However, the heavy rains are concentrated in a narrow strip along the western Ghats. After crossing the western Ghats, the rain-bearing air currents descend the eastern slopes where they get warmed up adiabatically. This results in a pronounced rain shadow area. The higher the mountains, the larger is the rain shadow effect. Towards the north, where the western Ghats are not very high, the difference in the amount of rainfall between the windward and leeward side is rather negligible. Although a few air currents from the main Arabian Sea branch are diverted northward towards Kutch and Thar Desert, these currents continue up to Kashmir without causing rain anywhere on their way. In fact, an east to west line drawn near Karachi in Pakistan practically marks the limit of the monsoon rainfall. So now there is a question that we have to deal, that is why no precipitation in Kutch and western Rajasthan. There is no mountain barrier to tap the advancing winds, as the Aravallis have an almost north-south axis. They fail to block the passage of these monsoon currents, which rather blow parallel to the Aravallis and lift them. The monsoon currents heading towards Rajasthan are rather shallow and are superimposed by stable anticyclonic air. The hot and dry continental air masses from western Pakistan or Balochistan are drawn towards the thermal low developed in this region. These air masses check the ascent of air and absorb its moisture. These conditions are unfavorable for precipitation in Kutch and western Rajasthan, where desert conditions prevail. Some of the currents from the Arabian Sea branch manage to proceed towards Chutnagpur Plateau through the Narmada and Tapti gaps. These currents ultimately unite with the Bay of Bengal branch. So, now we'll go to the second branch, that is the Bay of Bengal branch. This branch is active in the region from Sri Lanka to Sumatra island of the Indonesian archipelago, like the western Ghats of India in case of the Arabian Sea branch. The windward slopes of the west coast mountains of Myanmar, such as Arcana Mountains, get heavy rainfall when the main monsoon currents of this branch strike the Myanmar east coast. And on the west it was recorded as 425 centimeters during the month of June-September period. As in case of the leeward sides of Western Ghats in India, here too, the rain shadow effect is pronounced on the leeward side. A northern current of this branch strikes the Khasi Hills in Meghalaya and causes very heavy rains. Mysore near Cherrapunji, situated on the northern slopes of Khasi Hills, as the distinction of recording the highest annual average precipitation in the world. This is because of its peculiar geographical location. Mysore is almost considered as the flanked on all sides of the Garo Hills, Khasi Hills and Jayantia Hills, except for a gap through which the rain-bearing winds enter and are forced to rise, thus yielding the heaviest rainfall. Shillong, a mere 40 kilometers away on the top of Khasi Hills, receives only about 140 centimeters of rainfall during the month of June and September. Another current of the Bay of Bengal branch takes a left turn at the eastern end of the low pressure, roughly the Bengal Delta. From here it blows in a southeast to northwest direction along the orientation of the Himalayas. This current causes rainfall over the northern plains. The monsoon rainfall over the northern plains is assisted by west moving monsoon or cyclonic depressions called westerly disturbances. These are formed in the Bay of Bengal and move along the southern fringe of the northern plains, causing copious rains there which are vital for the rice crop. The intensity of rainfall decreases from east to west and from north to south in the northern plains. The decrease westward is attributed to the increasing distance from the source of the moisture. The decrease in rainfall intensity from north to south, on the other hand, is due to increasing distance from the mountains which are responsible for lifting the moisture-laden winds and causing orogenic rainfall in the plains, especially in the foothills. The two main branches of Indian monsoon winds follow different courses, but originally they set out to fill the intense low pressure void created in the northwest of the subcontinent. The two branches meet at the Chotnagpur Plateau of the total moisture carried by the two branches, only 20% falls as precipitation. The Arabian Sea branch is more powerful of the two because of two reasons. One, the size of the Arabian Sea is bigger, and the second one, most of the Arabian Sea branch falls over India, while most of the Bay of Bengal branch goes to Myanmar, Malaysia, and Thailand. So, now we'll go to the retreating or the northeast monsoon. Towards the end of September, the low pressure center in the northwest begins to disintegrate and eventually shifts to equatorial region. The cyclonic conditions are replaced by anticyclonic ones. As a result, winds start blowing away from the northern region. Similar anticyclonic winds blow from the Tibetan highlands and beyond. This is also the time when the sun makes an apparent movement south of the equator. Now the winds that dominate the subcontinental landscape are the ones which move from the northeast to the southeast. These conditions continue from the month of October till mid-December and are known as the retreating monsoon or the northeast monsoon. By December end, the monsoons have completely withdrawn from India. The retreat of the monsoon is markedly gradual in contrast to the sudden burst of the southwest monsoons. The retreating monsoons over the Bay of Bengal pick up moisture on their way, which is dropped over eastern or coastal Odisha, Tamil Nadu, and parts of Karnataka during the month of October and November. This is the main reason of rains over these areas, as they almost lie in the rain shadow area of the southwest monsoons. So during the month of October, easterly depressions occur at the head of Bay of Bengal, which moves south